Bonjour. I'm Jonas. Like Christopher just said, I work at Facebook Seattle on Nuclide, and I'll be talking about kind of like a hackathon or a side project today. And it's basically going to be a bunch of ideas and demos and prototypes, and I'm not launching anything. Nothing will be open sourced, so bear with me and bring an open mind. So the thing I want to talk about is called Combine, emphasis on the O. But it's just a working title, completely tentative, so we have a way to refer to it, okay? And this is what it looks like. It's a visual programming environment in the browser using open source components that you can kind of rearrange on the fly. And while you're changing, for example, values, the computation will update on the fly. You can like rename the nodes, you can select them, rearrange them, and so on. And the nodes really are a way of configuring computation, okay? So how is this made? Basically, there's a long list of these awesome projects that made it possible. Flow to iterate quickly, React powers the whole thing, Redux for storing the state, Immutable for actually, keeping the state immutable, Nuclide for building it, RxJS for wiring up these little nodes, and the React drag and drop project by Dan Abramov, and React Art, and a bunch of others. All right. So the first thing I hear when I pitch a visual programming environment to engineers is, I already know how to code, right? Why do I need to learn this other thing when code is just so much more powerful? And you have a point. Code is good a lot of the time. And where appropriate, when your task warrants it, you should totally use code. And so inside this editor, there's actually a code node, right? In this case, Babel, where I can just specify a custom function. And it doesn't just have to be Babel or JavaScript, right? If it compiles to JavaScript, you can run it in here. So you could make a closure script node. You could make a buckle script node with reason, and so on. So code is fine. It's just a tool, just like all the other tools. And there's many tools, so we should really care less about whether it's code in a textual or a visual sense. There's also some benefits that you can't really get with textual representations, and I want to quickly talk about them. So one is alternative representation. So if you think of a program as a way where data flows through an app, right? For example here, then that data is different from the representation, right? So imagine you're debugging this program which outputs coordinates for a triangle or describing a triangle in a traditional JavaScript debugger. What you'd be seeing is a single slice of the data at a time, and you'd only be seeing the data. Whereas in this visual world, we can kind of chain together alternate representations or nodes that do nothing else but pass on the input value, unmodified, but visualize it in a different way. So in this specific example, I've wired up a timer and some input parameters to this polygon node that just outputs a bunch of points. You can see it on the right. And I can pass on those points and pass them on and pass them on, and it's always just data. It's always just data. However, the alternative representation kind of allows me to reason and understand this data a little bit more intuitively, right? Because we're people, and people are great at recognizing things visually and understanding that way. Secondly, direct manipulation. So this is not just about visualizing data, but it's also about interacting with it, right? And a bunch of people have tried this with tools like Lighttable, for example, where we try to attach these UI controls to code. And it's a little bit hard because you can't really know what to attach to, right? It's hard. It's like a hard UX challenge. And in this visual environment, it's not as hard because we have a good metaphor for where to put stuff. And to get a little bit more concrete, I have an example of direct manipulation. So I made a node where you can draw using the mouse, right? And the output of that is just a bunch of paths. Pardon my horrible drawing skills. And you can see in the middle of the data, and in the top corner, the visualized path again, right? So now what if I want to actually manipulate that data? We could build additional nodes, right, that take an array of paths and manipulate that path. For example here, I made a translate X and translate Y node that just suck in a bunch of paths, and then you have a slider to manipulate the location. And similarly, you could build that for scale and rotation and any other kind of transformation that you might want to apply to data, right? And it's not just limited to a single component. Like this slider could be an input field. These two sliders could be in a single component. You could build another component that is a 2D input, which is much more well-suited to manipulating 2D, right? Because we have a mouse. Or you could move it into 3D. Last night I was like, why not just 3D, right? Or like, why can't we do this in 3D? So I just built like a WebGL node that generates a cube geometry and then exposes a bunch of parameters that we can hook into. And the parameters that are actually being exposed is kind of up to the programmer who is creating these wrapper nodes. More on that later. Does that kind of make sense? Okay. I want to step back a little bit from the specifics of the editor and just talk about TTP. This should be our metric for a lot of people in the room. Time to product, right? Like no matter what your day-to-day process is, agile, waterfall, this thing, like it's always about the same thing. It's about time, right? We don't have enough of it, and we're trying to like squeeze in more development into less time. And we're doing that because we're trying to build the right thing in as little time as possible. And there's a solution for that. It's been around for a while. It's called prototyping. And now prototyping has different stages. You can start out just describing things visually or on a whiteboard or something. You can do paper prototypes, you can do advanced prototypes, and so on. And as the fidelity of your prototype grows, so does the cost of change and the cost of implementation. And I think we can do a little bit better. The state of prototyping in 2016 is a little bit saddening almost because of this. So this is a tool called Quartz Composer, right? Designers use it to create prototypes and mock-ups in high fidelity. So a designer is coding here, okay? Let that sit for a second. Like, we're so focused on like code or like non-coders, non-engineers, engineers, like it doesn't matter. It's all tools, right? And so this person who made this mock is coding in a visual language. That's like a great, profound insight, I thought. And secondly, what is the saddening part is that the output of this app that's going to animate, and it's going to be beautiful, and it's going to maybe even have some business logic, right? The output of that whole process, the artifact, is a beautifully rendered MP4 video file that's shipped to some developer, and then he gets to go in frame by frame, or she, and re-implement it in React Native or React or whatever it might be. And it's a little bit sad because we should just have tools that allow us to reuse this code more easily, right? And iterate rapidly. This is not the first time somebody's built a data flow language or a visual programming environment. It's actually been done hundreds or thousands of times. This is a really cool example. I like this a lot. It's called Scratch. It's built, I think, on top of Smalltalk, and it's a way to teach children how to program using these kind of imperative building blocks like Legos in a sense. I think that's really cool. And there's hundreds or thousands of others. Yahoo Pipes might come to mind as a browser-based implementation that was shuttered. It was more for like authoring back-end jobs. And so like this project is more about a real-time interaction with the data. So even though there's a lot of these pre-existing tools, there's a couple of downsides that I want to highlight and that I think something like Combine could address, right? First of all of the runtimes are platform-specific. So a Quartz Composer mock cannot exist outside of Quartz Composer, at least not in the interactive form, right? Similarly, a Scratch program only lives inside of Scratch. And that's different for Combine, where it's built in JavaScript, and JavaScript can run pretty much anywhere. Secondly, because the ecosystems are kind of closed, we get limited network effects. And we already have a solution for that. It's called the internet. It's a really powerful thing. And it's a little bit sad that we are not using it more, right? Like we have a package manager, we have a way to push out code and pull in code and like share stuff, and yet it's still incredibly tedious. So making that easier and lowering the bar, I think that's worthwhile. And lastly, limited UX, right? a lot of the visual programming tools, they have inputs and outputs, but they lack tools for alternative representation and direct manipulation. And I think ultimately that's where a lot of the benefit of Combine comes from. So how do you actually go about instantiating a node? So there's a fuzzy search here where you can look for whatever you're trying to put. It also searches aliases and tags and might support documentation search or something like that. I've also kind of wrapped a lot of the JavaScript standard libraries so that you have access to like math.sign or math.random, something like that. And it's all done fuzzily, right? And this type of like instant instantiation through search, I think is really powerful. And we kind of need more of that. Does anybody know this website? I love it. It's called React Rocks. It's basically Pinterest for React components. And there's like hundreds or thousands of these really awesome component projects. A lot of them you can just like add to your own app. Except that they all kind of live in their little GitHub house and don't really know about anything outside of it. So they have their own build systems. It's not clear what the APIs are. There's no like static interfaces like types. So it just makes it a little bit hard to consume this stuff because you have to like find a thing using Google or GitHub, npm install it, figure out a way to like build it and integrate it and so on. So how cool would it be if we had this in the browser and we're able to just like play around with these tools and like try it out quickly. So I've built a weather app that pulls in one of my favorite React Rocks projects. It's called RD3, so a React D3 wrapper that lets you do these charts. So it basically lets me render a bar chart. And I've wrapped it so that all I have to do is pass in an array of x, y coordinates, and that will render as a bar chart. And because this is the web, right, we can actually consume a web service. So Yahoo has like a public weather API that I queried. And at the top top left, we're just fetching that content through an AJAX request, okay? So I paste the URL here. The URL represents a JSON response. And as soon as I change the URL, the browser goes and fetches that data, and then I just extract parts of it, and I render the city in a large text, and I render the data as an interactive chart, okay? And remember, it's all just data. So I can like add this tab node, which is the equivalent of like console.log, and inspect the data at every given point by branching off with an additional connection. And so having these wrappers at our fingertips for a lot of the components is super powerful because like how long would it normally take you to instantiate a bar chart, including like searching for it on the internet and so on? It's a long time. And even like going from like the order of minutes to the order of seconds is an immense improvement in how fast we can iterate and build products, right? And search in particular is a little bit underpowered currently. Because you guys all know this, I actually needed a heap at some point while building this, and I'm not like ranting about any of these projects. It's amazing that they exist, but I just think that we are sitting on a giant pile of data and signals to figure out which heap package is the right one for a given job, right? And yet, it's just kind of arbitrary. So in the ecosystem in general, there's like name squatting going on. So the first person who claims a package name happens to be the canonical implementer, and like now we're trusting them. I don't think that's ideal. So I've come up with kind of a wish list, and I have no way forward to like actually fix these things. I'm just asking some of you to like go out and fix it, so that we can then pull it into Combine and like make the whole thing more powerful. So NPM already provides versioning pretty decently. The namespacing is limited. I think we could do better. Statically typed interfaces in all our modules would be incredible because you'll see. And lastly, I think we could do a better job of annotating stuff semantically using some sort of ontology of like what stuff, like what packages actually do, using documentation, and of course, quality and usage data. You could think of like a Yelp for packages. Why hasn't anybody built that yet? I endorse this. A brief note on static typing. So I was talking to Jeff. I hope you guys saw his awesome talk yesterday about Flow. And it turns out Flow is written in OCaml. And OCaml can be compiled to JavaScript using a project called OCaml to JS or something. And so Flow can be compiled to JavaScript. And so we can use that to statically reason about which nodes can be connected versus not. So you may have noticed when you're instantiating a connection, the engine kind of pops open these little yellow boxes with numbers. Those are shortcuts, so you can just kind of type the number and very quickly establish that connection. And the engine only suggests valid connections. If they're unoccupied, or if the type from output port to input port can legally flow. And then we sort that using the distance from the origin, so we have more relevance. So static typing is powerful, and moving more, or like having more static typing information in the ecosystem would be even more powerful because network effects. I want to talk a little bit about how the thing is built. And I want to give things names, just like the project itself, so we can have a shared understanding. This thing is called a node. It's just a representation of a bunch of things, right? It only exists in like the world of the editor, not really in the world of computation. It only represents what's called the runnable. And the runnable runs the actual code. So if you're generating a triangle with the inputs of radius, vertex count, and angle, then like the implementation is just a pure function of like those parameters. And the node just represents that. It doesn't actually like include it. So there's these connectors and ports, and we use, like I said, static typing to figure out which ones are legal to be connected to each other. And lastly, there's an optional React component on every node. And that React component encapsulates all of the side effects. And that's pretty important. I'll talk about that in a sec. Using this example. So you guys remember the drawing example where I was translating the path in the x direction? So let's look at that node. It's interesting because it has both input and its own state and its own component. So this is what the spec looks like for this translate x runnable. It's got a name. It's got a bunch of aliases and tags that make it searchable. It's got a pure implementation function. It's got an optional component. And then it's got a thing that just a bunch of descriptors, basically, for the inputs along with their types, the output type, and the state property is basically like the initial state of the node. The implementation itself. So it has to be pure for a variety of reasons. First of all, pure functions make our lives a lot easier, right? Pure functions means that, or a pure function is when you pass input to a function, you always get the same output, right? So pure functions are great. They're easily composable, or basically automatically guaranteed to compose well. They're memoizable. They're like referentially transparent, which means that you can replace the output, or like you can replace the call to a function with its value. And in a pure function, that's always possible. So that's pretty sweet. Because you can imagine building an app node consisting of like hundreds of nodes, and it's super complicated and maybe expensive, right? Because the implementation itself is just a pure function and not talking to any sort of UI and not performing any side effects, you could conceivably group those functions together into a single function because pure functions are guaranteed to compose, and offload that into, let's say, a web worker, right? And because they're pure functions and because nodes are already glued together using observables, meaning that like they are asynchronous by default, this will work transparently. And so this implementation concretely receives the state of the node and the inputs. And anytime either the state or the inputs change, the implementation gets called again and then forwards its output through the graph. And then the graph updates lazily. So it's important to capture these side effects explicitly, right? That's one of the kind of killer features of this model, I think. If your implementation is just pure functions, then you still have to have side effects somewhere, right? Side effects are a necessary evil. Like we all loathe them, but like we wouldn't be here if they didn't exist, because without side effects, you wouldn't have UI, you wouldn't have I/O input, you wouldn't be reading files, talking to the network, you wouldn't be calling math.random or consuming the time, and the list goes on, right? Side effects are like the root of all VC funding. Like, we wouldn't be doing this if it wasn't for them. And so we need good models to abstract side effects away, right? And so in this project, they're explicitly captured inside of those little components. And so specifically for the translate runnable, we have this component. It receives the state and input of the node as props. even the state. It's a little bit different from like traditional React. And then it receives an update state function that it can call with a new state a property, basically. And the engine takes care of versioning or like storing the state in a global atom. So we have a global state atom that's built using immutable.js. And for every node identified by the node's ID, we store the state and then inject it whenever necessary. So separating the side effects from the implementation is powerful. And that is coincidentally also what allows the whole like having alternative representations and direct manipulation, right? Because your implementation is different from the little side effect component. Observables are the glue of this whole thing. So I already kind of touched on it. Every node basically represents an asynchronous process. And you might think that, oh, what if I have just like addition, right? Like A plus B equals C. That's a synchronous function. Like, why does it have to be observable? Well, everything is an observable, and basically, we don't worry about that. A little primer on observable. How many people know observables? Oh, it's pretty good. So maybe I'll just skip through this real quick. If we have this example of addition, two numbers, and we add them together in an add node, this is what it would look like if you visualize the observable. We got 3 streams, one for every node, and every time the input nodes change, we use what's called the combine latest combinator from RxJS to recalculate the sum. And so that same model applies to the entire tree. And so it doesn't matter if you have synchronous computation or asynchronous computation, like the example with the fetch XHR request, right? It really doesn't matter because everything is an observable. And we can use observable combinators to affect the way this app behaves too. There's these combinators, for example, throttle, right? If you have an observable, you can throw the throttle combinator on it, and out comes a throttled version of that same observable. And so you could actually make just another runnable or a node inside the editor that lets you throttle interactively, right? Because everything is an observable. And it's not just limited to like AJAX requests, right? We also can do WebSockets. And so I was like, what would it take to build a little like high frequency trading app? And obviously it's like a super simplified version, but what's going on here is I have a node that lets you talk to a WebSocket, and I have a fake stock ticker web server running locally that just emits a random number every now and then. And then we can already kind of log the value of that and observe it. And so I'd like to graph it, right? That's like the bread and butter of any finance app, pretty graphs. And so I need to kind of buffer the past values. So I feed them into a buffer. The output of that is just an array of those values. And then I instantiate like an area chart. Should probably be a line chart, but and to be able to wire these things together, I still need to kind of convert, because the input is an array of numbers, and the input of the chart is an array of points. So I have this little wrapper, right? And boom, now we can. Thank you. And so this is really kind of the moment where it gets interesting, right? Because you see that you are literally interacting with the data as it flows. You can see it flow, and like there's just like a lot of potential for building your own wrappers and components to make this even better. And like there's no limit to messing around with this. Like I've made a slider component and I'm hooking it up to like the buffer size, and now you can like interactively change the buffer size while you're like consuming the WebSockets and everything updates. Like it's a good tool for education too, right? And that's, I think, a good another good aspect of Combine potentially. I also thought about what if we could like artificially limit the number of, or like the set of available runnables in the fuzzy search. Then we can teach people how to use like logic gates, right? Like everybody used that like crappy logic gate program in undergrad. We could do the same thing here, just limiting the subset to just logic gates or whatever. Lots of possibilities. I want to talk about the engine. So the engine is the thing that takes the state of the editor, including the connections and the nodes and so on, and recomposes the implementation graph, right? So it's the thing that chains together all the implementation, the pure functions, with observable glue. And it basically maintains a directed acyclic graph, because we would have like, we would do infinite looping if if we had cycles, so it can protect against that. And anytime the editor configuration changes, it reconciles the state of the editor with the state of the implementation. And only the necessary work gets recomputed, right? So if you remember the weather example, we have a fetch node. The fetch node only actually fires off a request when we change the URL, not when we, for example, add another listener, right? So the last node value is always cached. And so the whole thing is kind of inherently lazy. And so we have like a thing that can reconcile a tree and like do minimal work. This might sound familiar at ReactConf. It's kind of similar, a similar model where we have like, instead of a tree that, or like instead of reconciling a virtual DOM, we do the same thing for computation and asynchronous processes. There's one more thing that I kind of got thinking about, and that's like, what are apps, right? Apps are basically components with layout slapped on top, or like components rearranged in a layout, where components are just a bunch of side effects. And so similarly, or like similar to how we can run the pure functions in like a web worker or on a server transparently, we can also pull out just like the side effect encapsulating components and rearrange them together, and basically out comes an app. And I didn't actually get around to building this, but hopefully these boxes suffice to kind of drive home the point. If I'm trying to build a weather app, all I have to really do is like build another node that consumes a phone's location or something, pipes it into the fetch node, and fetches the weather for the current location, and then you'd actually have an app, right? You just have to kind of put like layout on top. And so if we bring that back to my point about static typing, right? Every runnable, every node has a static type interface, so we know what the inputs and outputs are. We could all of a sudden build equivalent components. So, for example, React Native gives you all these components, for example, for a date picker. And the props for that date picker are of a certain type. And so we can build an equivalent component with the exact same interface that is able to render on the web, because this editor is built on the web, and I don't think it would make sense on a phone. But the kind of key insight I had was that like we can replace the implementations, the actual components, as long as the interface is the same, and as long as those components kind of attempt to do the same thing, right? And my point about semantic annotations kind of comes in here. So let's imagine we had web equivalents of all the React Native like basic components. We could be building these apps inside the browser and then just reconfigure them into layouts and then push a button that exports the whole thing as a React Native app. Except what's running in the React Native app are not the shitty web component like equivalents that we only use for prototyping, but the actual native components. And that's kind of how I think we can bridge the gap from like that's how like designers can break out of Port's Composer all of a sudden, right? Because the thing that comes out is reusable. Okay, that's kind of the insight here. So in summary, what was this all about again? It's basically a prototype. It's not a project I'm launching or anything. It's just I just built this for this talk to kind of see how hard it would be. And it's a prototype for a new visual programming environment. I discovered a couple of things that are interesting, like separating pure functions and the side effects of things and making that separation explicit. I had a lot of fun with observables and RX, had a lot of fun with Canvas and so on. And I think it's really worth thinking about how we can make tooling better, right? We all spend like at least 8 hours a day or however much in front of our screens building stuff, creating things, creating digital things. And it doesn't matter if these things are apps or photos or blog posts or videos. Like, it's hard to create stuff digitally, and I just want to make that easier. And so this is kind of a step in that direction. So thank you, and I'd love to hear your feedback.